Today for section 2.7, it is called Try, Test, Revise. I forgot to write that up here, so I will do that here quickly. 2.7, Try, Test, Revise. What this basically is guess and check. We have a problem. We might not get it right the first time, so we're going to try a different way the second time. Do you have to work hard at these? Yes, you do, but I know that we can figure them all out if we're just trying and we don't get lazy. So for number 1, it says Bonnie has 16 coins in her pocket worth $1.50. What are 2 different combinations of coins she could have in her pocket? One way I can try to solve this is by starting with dimes. So if I start with dimes and I ask myself, well, how many would I need to get to $1.50? I would need 15 dimes would equal $1.50. That doesn't quite get me there. That gets me pretty darn close though, because I need 16 coins. So if I took away one of those dimes and I had 14 dimes, then I asked myself, okay, I need 2 more of something. What 2 coins could I add together to make 10 cents? Why those coins are called nickels. So if I use 14 dimes and 2 nickels, I will get to my $1.50. That is one combination of coins that she could possibly have. Let's try to think of another one. Let's say I start with 2 quarters. Okay. Then let's say to my 2 quarters, which add up to 50 cents. Oops. Which add up to 50 cents. Let's say I added 6 dimes. Why not? 6 dimes would be 60 cents. So now I have $1.10 if I add 50 and 60 together. I still need 40 cents. So how many more coins do I need? I have 6, 7, 8. Right now I have 8 coins. I need 8 more coins. And somehow those 8 coins have to add up to 40 cents. I think I know what I could do. I could try 8 nickels. 8 nickels, 8 times 5 sure is 40. So now I've got my 40 cents there. $1.10 plus 40 cents would equal $1.50. So if I needed 2, I could use also 2 quarters, 6 dimes, and 8 nickels. You could come up with your own way to solve this as well. That's why it's kind of called test, try, test, and revise, because there's not only 1 or 2 answers. There could be many possibilities. All right, on this one it says, a cashier's drawer has some bills. $5 bills, some $10 bills, some $20 bills. There are 15 bills worth a total of $185. How many $5 bills, $10 bills, and $20 bills are there? So now the big thing to remember about this is you're going to have to do some playing with it. You're not going to be able to get the first, well, you might be, but it's going to be pretty tricky to get the right answer the first time. So let's try starting out with our largest bills, because I feel like that's the best way so that you can get closer to your total. So let's say I want to make $100 out of my $20 bills, so I'm going to use 5 $20 bills. How I'm going to make sure I keep everything straight, so I'm going to write equals $100. Now I might have to do some erasing, so bear with me. So if I have 5 $20 bills, then the next step is I'm going to say how many $10 bills do I need to get really close to 185. And I can't go over 15 bills. So let's say I did eight $10 bills. Then that would be another 80. My total would be up to 180. So then I would only need one $5 bill to get my 5 up. So my total equals $185. But let's see if I used 15 bills. 8, 9 plus 5. I only used 14. So while I got the right answer here, I did not use the correct number of bills. So that means I have to try it again. So let's erase. I'll try to erase it fast, but it doesn't look like this thing's going to go very quick. You do not need to erase from yours. I'm just going to erase from mine so that I have room to do another one. I'm going to keep the $100 bills, though, because I think that that's a good start for us. Guess it doesn't want me to erase that. Okie dokie, here we go. How many $10 bills should I try this time? I am thinking that I should try 7. I am going to try 7 $10 bills because 8 was too much. So I might as well try one less and see if I can figure it out from there. So if I have 7 $10 bills, that would equal to $70. And to get to my total of $185, I need 15 more dollars. If I have $5 bills, I would need 3 $5 bills to make $15. So now I've got my total where I want it. Let's check to see if we use the right amount of bills. 7 plus 3 is 10, plus 5 more is 15. We got it. So how I would write my answer is this part right here. 5 $20 bills, 7 $10 bills, and 3 $5 bills. Let's try another one. Okay, number 3 says, the Smiths have 2 children. The sum, remember, the sum means if you add their ages together, is 23. So if we have child 1 plus child 2, our answer is going to equal 23. The product, remember the product means multiplying. If I multiply their ages together, I will get 132. All right, so let's have the guess and check begin. If I know that the sum of their ages adds up to 23 years old. So I'm going to say I'm going to try to divide that by 2. I know I can't, but I can get pretty close, and if I did, I would get 11.5. So if I went up 1 and guessed, well, 1 could be 12, 1 could be 11, because that adds up. 12 plus 11 adds up to 23. Let's see what we get when we multiply them together. 12 times 11, 2, 1, 0, 2, 1, 2, 3, 1. We did get it. 12 times 11. Now, if you didn't guess that right away, then you just have to guess and check. Let's say I picked the numbers 10 and 13. Okay, I know right away, if I multiply 10 and 13 together, 3 times 0 is 0, 3 times 1 is 3, add a 0, 0, 1, I know it's going to be 130. So then I say, man, I got really close on that one. Let's try another one. So then I could maybe go up to 11 and 12 and see if that one works. Or if I don't get that close, let's say I guess they were 20. Oops, sorry. Let's say I guessed that they were 20 and 3. Let's move that back. Let's say I guessed 20 and 3. 20 times 3. 3 times 0 is 0. 3 times 2 is 60. Wow, that got us nowhere close to 132. So then I know my answer was way off, and I should try something that's where the numbers are both higher. So again, you guys, this is just a guess and check. You just have to guess check your work, but I really do want to see these. If they give you something where it says the sum of their ages, the product of their ages, I want to see some kind of a number sentence written out that you can check your work in. All right, let's try another one. Okay, so for this one it says the sum of Mr. and Mrs. Bergerson's ages is 100. Again, let's write that out. Blank plus blank equals 100. Okay, the difference between their ages is 10. So if I take the bigger number minus the smaller number, I am going to get the answer of 10. So again, I kind of like doing that where I divide it by 2. So I know that they're going to be somewhere around 50 years old. Okay, but if I have a 50 and a 50, I don't have that difference of 10. So what about if I tried 60 and, well, if I did 60, I'd have to do 60 and 40, but that's 20 years difference. So I can't be that. So it's got to be somewhere between 50 and 60, the oldest person. I'm going to go right in the middle and give a shot with 55. And if I want to know what the other age would be, I would have to subtract that from 100. Borrow, get my 10, borrow another one, get my 9. I'd have a 5 here. 9 minus 5 is 4. So let's try 55 and 45. So do 55 and 45 add up to 100. Yes, we just did our work here to double check that. Well, what about this? Is 55 minus 45 10? Yes, it is. So I would write they are 55 and 45 years old. That would be my answer right here. Again, please show me work. Please show me work. I really want to see this, especially if they tell it to you in the question. I really should see some number sentences so that I know what you're thinking and what the process that you're going through. All right, so for number 5, our question says a rectangular vegetable garden has a length of 5 feet. Okay, so let's draw a rectangular vegetable garden. Okay, it's got a length of 5 feet and a width of 8 feet. Better make sure we get our units labeled in there. 5 feet and 8 feet. If the length is increased by 2 feet, by how many feet did our vegetable garden, does the area increase? Sorry guys, I had it written in up there and I guess it somehow got deleted. So if you need the original directions, you can always go back into your book. It is number 5. Okay, so my first step is to figure out how much my new garden, the area of it, is going to be. I know how to find the area because I know the formula. Area equals length times width. Okay, so if I just do 7 times 8, then I would get my new area of the new rectangle, would be 56. So to get the difference, I need to find out what the original rectangle was. So how I can do that is the same way, plugging it into A equals LW. L times W, we're kind of past writing the times in, but I'll write it in for this one so we don't get mixed up. So I would get area equals 8 times 5, or 40. Now to find the difference means subtracting. So I would take the bigger number, 56, and subtract it by 40. That'll look like this. 56 minus 40. 6 minus 0 is 6. 5 minus 4 is 1. So then we can write our answer. The new garden is 16 square feet larger than the old garden. Sorry, I'm trying to fit it in here. I'll outline it in blue so you can see where our answer is. Alright, so hopefully this one will not get deleted if I don't mess around with it. For this one, number 6, it says trains leave New York for Boston every 40 minutes. The first train of the day leaves at 5:20 a.m. What is the departure time that is closest to 12:55 p.m.? So what I'm going to do is I'm just going to be adding 40 minutes. Remember, there are only 60 minutes in an hour. So if I get a time where it's like 5:75, that is way wrong because that's not a time. Okay, so if I add 40 minutes, I would get 60 here, so I would have to carry it over here. It'd be 6 o'clock. Add another. To make this go a little bit faster, I'm going to do multiples of 40. So if I do 40 times 4, I would get 160 minutes. So let's try adding 160 minutes. 160 minutes, or 2 hours and 40 minutes. How I figured that out is I did 160 divided by 60. 60 will go into there twice at 120. I'm left with 40 minutes left over. So let's add 2 hours and 40 minutes. So I would get to 8:40 a.m. Now I notice I'm not quite getting there as fast as I want to. I've only gone 3 hours. So I'm going to try another time again, adding or finding out a bigger number that is a multiple of 40. Remember, multiples of 40 is just like 40 times 1, 40 times 2, 40 times 3, 40 times 4. I know 40 times 4 will get me 2 hours and 40 minutes. I'd like a little bit more than that. So let's try 40 times 6. Let's try 40 times 6. 6 times 0 is 6. 6 times 4 is 24. So if I count up by 60s, I would go 60, 120, 180, 240. So I know that this right here is the same as 4 hours. Okay, so if I add 4 hours to 8:40 a.m., I would get 8, 4, 8, 9, 10, 11, 12, 40 p.m. So right when it hits 12 o'clock noon, in the middle of the day, it turns to p.m. So I would get 12:40 p.m. My opinion is that 12:40 p.m. is pretty darn close to 12:55 p.m. So if you want to catch that train, you better try to catch the train. If you need to leave by at least 12:55 p.m., you better catch this train so you can be a little bit early and not late. So there we found our answer. 12:40 p.m. is the closest train that leaves to 12:55 p.m. Again, we're just guessing and checking. I didn't know what the answer was, so I guessed. I saw that I was going too slow, adding 40 every time. That's going to take me forever. So I said, let's try to find some multiples that I could add to get there quicker. That's my main goal, is I want to get there quicker, but I want to make sure that I get the right answer. So let's try another one. All right, number 7 decided it wanted to erase as well. So I'm going to have to try and figure this out. It is in your book, so you should have that out next to you, as I asked at the beginning of this lesson. And it says Lovell is 16 years old. Okay, so Lovell is 16. That's a very interesting name. Lovell is 16. Lovell's age is the same as Rafi's age divided by 3. So I could easily write a number sentence for this one. So it says Lovell's age, which we know Lovell's age is 16, is, so whenever I see is, I'm going to write that equal sign, Rafi's age divided by 3. So to solve for R, I need to do the opposite. Right now I'm dividing. So the opposite of dividing is multiplying. So I need to multiply both sides by 3. Multiply by 3. So these 3's would cross off. I'd be left with the R for Rafi. Then I just need to do what is 3 times 16. 6 times 3 is 18. 3 times 1 is 3, plus 1 more is 48. So Rafi equals 48. If we want to test that out, we could always go back up to here and do what is 48 divided by 3, because that should equal Lovell's age of 16. 3 goes into 4 one time, minus that 3. Bring down my 18. 3 goes into 18 6 times. My answer checks out. So Rafi is 48 years old. All right, now your job is to finish doing the rest of the page up until 13. 13 is a challenge problem, so don't beat yourself up too much if it's too tricky to figure out. So just do number 8 through 13 for your homework tonight, and it should be somewhere around page 98. We did most of them together, so you just have a few more to do on your own to make sure that you are understanding everything. Thanks for watching.